Thank you so much, Danjo, and it's great to be back here on this stage. Today, I'm going to talk about the digital thread, and you could say, as you might know, Configit has been working with manufacturing companies for quite a while now. For 25 years, we have helped solve configuration problems, and therefore it might be a little bit surprising that it's only until recently that we introduced a standard way of saving and loading configurations on our platform. But bringing out Ace in the cloud suddenly made it possible for us to see the benefit of having a consolidated place for saving and loading configurations. So what I'm going to do today is to take you through some of the use cases that we have looked at that was driving our decision to build this capability. So before I go into the details of those different use cases, I think it's in order to have a little bit of background in place. So let me just start by giving you an introduction to how the digital thread is defined by Gartner. And of course, you can find different solutions out there or different definitions. So Gartner defines the digital thread as a framework for enabling connection, orchestration, and presentation of data from multiple factors influencing products and/or processes. And the key word here is over the life cycle of the product data. This is a fairly high-level, broad definition, but what the key word here is the life cycle. So the life cycle that we're talking about here is the life cycle that goes from our engineering space, could be the PLM system that we looked at earlier today. We talk about the configuration as it has been as designed. Later in the life cycle, the product gets ordered. That's the whole CPQ process where you need to go through the different stages of quoting and ordering. At some point, it gets an order. You get it into the manufacturing side of things where you build it. Then you deploy it, you install it, you deliver it. At some point, you might service it and upgrade it. So that's the life cycle aspect of the digital thread. The thread part, of course, comes in because you want to make sure that these different configurations are being linked to each other. So you can trace back and understand the details of where these things came from, how they were changed, and why they were changed. When we talk about configuration, we talk about configurable products. We talk about products that have a lot of variability. It could be a car, it could be a complex machine, an MR scanner for Philips or something like that. And the key way to manage this variability is in using features and options, or sometimes called options. So features are what defines the variability of a product, either from a technical perspective or from a commercial perspective. And the features are tied together by constraints or rules. And that leads to a set of configurations that satisfy those constraints. That's sort of the space that we are working in. Once you have a configuration, you can use that to derive all kinds of additional information. You can use it to derive the bill of material. We saw a few examples of that earlier today. You can derive pricing, documentation, CAD drawings, and whatnot. So the configuration is the features is what's sort of the DNA of your product. Now, I want to point to some confusion that often arises in this area, and that is that the word configuration has two slightly different meanings. If you are in the engineering space, in the systems engineering, and work in configuration management, where you see the word configuration, you will find a definition of a configuration which is you could say it's a snapshot, a versioned snapshot of all the artifacts that makes up a particular variant of the product. So this is more like in the space of baselining, where you want to track the changes happening to the individual artifacts. Now, when we talk about a configuration, we talk about how a product gets, how the variability of the product seen from a capability perspective, seen from a feature perspective. So a way to illustrate this difference that I think I also used last time is that if you talk about a configuration change in the configuration management space, it could be something like illustrated here with a little silly example of a t-shirt, but it could be something where you basically replace some internal of the product. In this case, the color has changed slightly, but from a customer perspective, it's the same product. Whereas if you talk about a configuration change in the feature space, then that change is from one set of features to a different set of features. In this case, it's the color feature that has changed. And everything I'm going to talk about today is going to be about configurations as defined on the right-hand side of this picture. So let us dive into some of these use cases that we have been used and have worked with our customers to drive the development of Ace Thread. And I'm going to present 6 different use cases today. They cover many areas of the circle here. The first 2 are about servicing. They're about reducing service time and how to retrofit existing products with new capabilities. We have a use case about how you can optimize a product. We have use cases that talks about how you can improve collaboration using configurations. We also have examples how configurations that you have stored can be used for validating the models that you are working on. And finally, I have a little bit about how having a centralized configuration store can help you in supporting regulatory compliance. So the first use case is a scenario where a customer has configured a complex machine, and that machine has been constructed and delivered and is up and running. Now these machines are typically highly complex, they are expensive, and they run for many years. So naturally, after a number of years, it's customers would like maybe to upgrade them. And the challenge here is that you need to make sure that that upgrade process is smoothly. So the approach that we can take is that we can, based on the configuration that was used when you configured and sold the machine in the first place, think back to this thread, we know how it was configured. We can take that configuration, we can apply it to a product model, a current one, and that application will most likely result in some conflicts. Now, the configuration engine can help us in how to resolve those conflicts. So basically, it will tell us that if I want this new feature, there are certain other features I cannot have, and I have to deselect them. But we can use the configuration model that has been defined to basically analyze and help us pick the right and optimal way to resolve those conflicts. And by doing so, we can generate the parts that we need, and we have a guarantee that when the service technician goes out to the customer, brings down the machine, replaces all kinds of parts in there, and brings it back up, then it will work immediately. And you can imagine the challenges that a service technician has if this is not the case. If he brings it up and it doesn't work, what should he do? It can be very difficult to find out what the reason is for that. Now, this is an example, this was an example in the upgrading of a complex machine. A little bit similarly in the service area, we also have customers that also want to upgrade existing products. It could be a tractor like shown here, that comes down to a dealer and says, I really would like this new fancy capability, GPS something. Is that possible to get on my tractor? So unlike the previous example, we're not going to start pulling the tractor apart. We're just going to help the customer figure out whether a certain capabilities can be added to this existing product. And the challenge being that the product might be several years old. You can also imagine that this is a software upgrade, that we have an existing product with an existing software version. And the question is, can we add a software module, a software capabilities in this existing product? Now, this is a little bit different because here we are not going to change the parts necessarily of the product. We're just going to help in the sales process of figuring out what will actually work here. And the way customers do this is that they build product models that are specific around upgrading. So they allow all the existing configurations and then they have rules that specify whether or whether not you can have a certain upgrade. And this is a great way to sort of extend the life of a product and basically sell more to your existing customers. A different use case here is about reducing cost. This is a challenge where manufacturers that do configurable products, they have a lot of variability often. There are a lot of things you can choose from. There's a lot of push from the market and from the salespeople to keep adding more functionality, more features to the product so that they can address more and more markets. Now, the challenge with that is that adding more features also drives engineering cost. So how do you best balance the variability externally and the complexity internally in your bill of materials? And I have brought here today an old example from Audi. This was an example where we looked at this part from a steering wheel, and as you can see in German here, there are different things on a different levers on this part, and they control different functions. So if you have an adaptive cruise control on your car, then there will be a lever on this particular component. So there are different options that drives the part that actually goes onto the vehicle. Now, if you look at all those variant drivers that controls this particular area, you'll find that there are a handful. There's probably 10 or so. And they're the one listed in the columns of this tree. Don't worry, you cannot read the details of the tree. I'm not going to go into all that. But basically what this is illustrating is that there are a number of different paths to it. And what you have on the right-hand side is each of the different valid possible components that you have here. And if you do this analysis and start adding the probabilities of the sold orders, so this is where the configuration store comes in again, where Ace Thread becomes relevant. If you can find all the orders that have been sold over a period of time, you can easily calculate what is the probability of each of these choices, and you can classify them as some that are high probability, they are green, and low probability, they are reddish in this diagram. And based on that, you can start doing some analysis. You can start saying, okay, that's interesting. And in this case, it turned out that only 7 of the parts, they had 96 different parts, 7 of which covered 80% of their sales. So you can dig into this and you can start on understanding that if we remove certain features, or we can also decide to bundle things up. So you always get, whenever you get feature A, you also get feature B. And if you do that, then you will basically remove some of the internal complexity. You'll remove some of the parts internally. Having a centralized place to store configuration, that seems like a fairly basic thing, but it turns out it's an enormously big help when you want to collaborate with people. You don't need to send them around in Excel sheets and other types of data. You can just reference a little bit similar to how you can reference a Google Doc or a Word file instead of sending it around as an attachment. And we have seen that as being very useful in different scenarios. We have, for example, seen that you would like to have certain key configurations that you do the verification and validation. That's why I put in the V model there on the right. When you are designing your product, you cannot test all the billions of different combinations. So what you end up doing is that you pick certain configurations that are particularly interesting, and these you save and you track during the design process. So these are the configurations that you take through the V model. This could be like the minimal configuration. It could also be the fully loaded one, and then 10 or 20 so in between that are representative and covering sort of the common scenarios. We also see a need to save and share configurations when you have customers that work either a CTO, but sometimes with an ETO process as well. There needs to be communication going from customer to salespeople and back to the back office engineering to understand whether a certain ETO option is going to be possible or not, and whether what the price is going to be. And in that dialogue, it's very useful to be able to reference back to the configurations in a shared way, so that the CPQ tool and the PLM system share the same view of what it is that has been offered to a certain customer. And finally, from a simple case, you could say if there's a situation where suddenly there are questions about why can't we sell a certain option in the French market or something, then that configuration can easily be sent back to the modelers who are responsible for the configuration models. They can bring it up in the analysis tools. We just saw a few examples of that from Jesper's talk. They can bring that up, and they can analyze it and give the feedback to whoever. So those are some of the examples where just having a consolidated way, a single source of truth for storing configurations is not a lifesaver, but a time saver. Finding errors in your models is quite difficult. You can analyze them in different ways. We just saw a great example of that from Jesper's talk. But you can also use previous configurations that you trust were right, and make sure that when you do a change to your model, that all the existing configurations are still valid. So you can imagine that you have an order bank or all the sold orders from the last year, and whenever you do a change to the rules in the model, basically you test out and make sure that all those configurations that you have are still valid. If they're not, then you need to look into it. Either it could be that you have made a change that they will no longer be valid and you need to get them updated, or you have made a mistakes in your rules. It's a very simple, efficient way to do validation of the models. The last use case I've brought with me today is about regulatory compliance, and as many manufacturing companies are quite aware, the number of regulatory constraints that they have to live up to is increasing, predominantly due to environmental rules and sustainability. And on the diagram here on the right, you can see that this is mostly in Europe, but it's coming around the world. So we can just as well get used to the fact that there will be an increased number of constraints and regulatory rules that we have to satisfy. We believe that many of these rules can actually be captured in a product model. So you can write them as rules in the model, and thereby you can guarantee that they always are satisfied. And this is a great way to handle regulatory compliance. But we also see examples where the digital thread really becomes important. So for example, there's a EU directive about the digital product passport, and it basically says that any product that you can buy, you can trace back and understand all the elements that was in that product. Where did they come from? What was the CO2 footprint? And so on and so on. Now, for standard products, this is a fairly, I wouldn't say simple, because it's not. And it brings a lot of complexities in terms of your supply chain, but it's simple in the sense that a non-configurable product, you can basically put a QR code on the product, and you can scan, and it will bring you to whatever website that provides the information. But if you imagine a configurable product, there won't be two identical configurable products. There won't be two identical cars configured out there, because there are so many different choices to make, so that probability of two being equal is very low. So instead, what you have to do is that you have to have a centralized store where, if you need to do this type of tracking, you must be able to look up the configuration that was on the street on your car, and use that configuration to look up all the relevant elements of this product passport. So this is sort of an example where, for configurable products, that variability you have to deal with not just in the engineering and the sales phases, but you also have to deal with it now all the way out to the products as they have been delivered and is being operated out there. So that was basically what I had today. I have taken you through 6 different use cases that have led us to develop the Ace Thread. We are still working on this. We have released the first version of Ace Thread last year in our Ace 7. It is something that we believe can bring us a lot further in the end-to-end support, and in particularly in the service area, we believe that having a strong traceability of configurations that go all the way back will be quite important. So with that, I just want to say thank you out there, and back to you then, Joe.